All right, people, let's check out the Ferland Engineering Education Design Center foundation. So here's a wall footing. You can see that there's rebar sticking up out of it, so that was cast into the footing itself. And then these two 2x4s going along here are the edges of the wall form, probably. And if you look over on this side, there's, we got some wall poured. A little rebar sticking out of the end of that too. So in the drawings, the wall footing is right here, 1 foot high by 2 feet wide. So here's finished footing you can see all the way along the wall, but they ended their last wall pour right here, so you can see the rebar in the wall, right? There's one grid mesh on the inside of the wall and one on the outside of the wall, and they go all the way up with that. That ties into rebar, like here, that goes down into the footing, right? So there's an L bar that's in the footing that comes out to there, and then they tie more bar onto it, and then they'll place the forms around that for it. Here's some of the bent bars that go in the footings. Short part down in the footings horizontal and the long part vertical going up. So in the rec center, the wall actually goes from the top of the footing up to the top of the shelf, over 6 inches, up to the top of the wall, across, back down to the top of the footing, and there it is. So just to review then, there's the footing right there, and I'll hatch this in so you can see it a little better. I'll just put a little pattern in there. So there's the footing. Then the wall is here. I'll switch the color and make that blue. And a little bit different hatch. And I made it red anyways. There it's blue. Red is the footing, blue is the wall. So in plan view on sheet S101, we see that there are 4 different wall and shelf heights. There's 1 set, there's 2 sets, there's 3 sets, and here's the 4th set. I've kind of outlined, there's a blue box, there's a solid blue box, there's an open blue box, and there's a solid blue box. So we've been looking at this section on S502, section 4 on S502. So let's zoom in on that part of the wall. I just moved something. And take a look at this. So right there, there's the footing is shown for the wall as being there and there. The actual footing for the rest of the wall goes way out and around and all over the place. But what we're going to do for this assignment is assume that the wall is just like that for its entire length. So I can just keep carrying that line all the way up. Something like that. All right. So the footing we're going to assume for this wall is just the 2 feet wide. Same on the other side. And so that's kind of what it looks like, okay? So the next thing we're going to have to do then is figure out the length, which isn't very pretty because the dimensions don't line up. That's the way dimensions are typically in drawings. You've got dimensions that are related to structural steel, dimensions that are related to foundations. The column lines are primarily structural steel. And so the wall heights are concrete. So you can see you got 32 feet here, but that extends a little bit past the column line. And then we've got 20, let's see, the next one down is another 32 feet here of wall and 24 feet here. But the problem is going to be how much is this little piece that doesn't line up on the end of the wall. So from column line F to there, right, moving up to the other end, this little piece that I just marked here, right? Make that green. I always thought I'd make that green. So if we add the 32 and 32 and 24, that comes up to 86 feet, right? If we take 21.6 and we multiply that out by the 4 bays, that also comes up to 86 feet. So I just go ahead with these dimensions and calculate out those concrete volumes. Just remember to document any assumptions you make. Like if you want to do an average height along there or something, that's fine too. Just make sure you document what you did. Hope that helps.